Hello, and welcome to Lesson 5, Exploration 1, Graphing. By the end of this lecture, you'll be able to give reasons for looking at data, critique and suggest improvements to graphs of data, describe and follow the process of creating a plot in R, and customize its aesthetics and mappings. So let's say you have a question and have collected a data set. What's the first thing you do? You could probably guess at some of the starting points for the research process, but I would say the first place to start is actually on the bottom left here, graphing the data. We've talked about the 4 different steps of statistical analysis: initial analysis, planning, testing, and concluding, that we're going to cover in this course. And remember, we're doing this because initial analysis gets you familiar with the data and understanding what you're working with. Planning is deliberately thinking about what your tests and models require and setting that up. So you actually are really carefully choosing the tests that you're going to use, doing your tests or models, and then finally concluding and writing it up to communicate it. But you can break apart this process. There's lots of ways of talking about the process of applied data science. And one way to do this is this model right here. This is from R for Data Science, the recommended textbook in the course, where you import data, you tidy it, and then you understand it. You transform, visualize, and model. Finally, you then communicate it. And initial analysis maps onto this transform and visualize part, whereas we're splitting apart modeling into planning and testing deliberately because we want to understand the requirements for each of the tests that we talk about. Conclusion maps to communicate in this case. So let's focus on that initial analysis part. And specifically, we talk about transform and visualize. Again, this is all from R for Data Science, which is a recommended textbook in this course, not required, but it is available online, so you could probably take a look at it anyway, and I strongly recommend that you do. It's some great resource. We're going to use it for practical data science topics, especially early on in this course. So first, why look at data? Can't we just check the summary statistics? We just talked about mean, variance, median, different kinds of summary statistics that can describe a distribution. The problem is, even if you just look at this data, it gives you a bit of information, you're going to miss something. So if we have this mean of y, variance of y, mean of x, variance of x, and a correlation between the two, you probably would expect data like this. But you could also get data like this, or like this, or like this. This is known as Anscombe's quartet, and it's an example of how you can have the same summary statistics with dramatically different data sets. Each of these data sets tell a different story. One tells one of correlation, one tells about a quadratic probably relationship, one talks about a different linear relationship with an outlier, and of course the other one talks about like a clustered group. And you could drive this even further. This is the data source dozen from Autodesk Research in 2017.
That can be used to demonstrate the importance of visualizing your data and may serve as a starting point for new data anonymization techniques.
So you can go through any of these, and in fact, almost arbitrary data sets, as long as they satisfy certain requirements, while keeping the XY mean, standard deviation, and the correlation between them the same. So data tell stories, learn how to read them with Anscombe's quartet, or whatever it might be. So now that we think that we might want to graph this data, what makes a good graph? Well, let's take a look at one example. Is this graph good or bad, and why? Take a second and make a guess. First of all, I would say it's a bad graph. It's 3D, which means it's hard to see values and compare. You have some occlusion in the data. There are patterns, which is unnecessary and distracting. There's cylindrical bars. Why? Why is that trying to tell some sort of a story? What's that mapping to? And there's poor labels. The number. What do you mean by number? What are the units here? Are they whole numbers, or do they need to be decimal points like it's got here? You might be able to transform this graph to something like this, which is 2D. It's easy to see the values and compare them. There's no distractions. It uses minimum ink, and it has descriptive labels. Number of obsessive thoughts or actions per day, in this case. This is an example of reducing chart junk. Visual elements in charts and graphs that are not necessary to comprehend the information represented on the graph, or that distract the viewer from this information. This quote is from Wikipedia, but it's originally derived from Edward Tufte, who is a data visualization expert. And you can also think about the data to ink ratio as a way of quantifying or thinking about the kinds of chart junk that you have. So the ratio of data ink that's used to present the data, to all the ink in the chart or graphic. Again, this is from Edward Tufte. So if you look at this, you can see that there's quite a lot of chart junk. There's a bunch of extra lines and borders. And these extra patterns that are going on. Is that really adding to the data? If you look at this, you see this, it's in 3D, which is bad to perceive. These values are really difficult for us to actually imagine, or to visualize, to compare these different data points. You've got these unnecessary patterns going on. There's even these little like shadows, I think, going on. Like that's not adding anything to it. To really highlight this, you might look at this graph right here. This is the grid in the classic Mary train schedule, and it's very active. You have lots of ink here. You could thin the grid a little bit. This helps to bring out the lines. It shows where the different trains connect at different stations. But if you use a gray grid, it really shows the data a lot better, and it still gives you those reference points that you need. So you can think about how you might reduce the unnecessary visual noise in your graphs, this junk, and really try to bring out the data to make it easier to understand for people. Many of these ideas have been developed and advocated by Edward Tufte, who we mentioned, and his books are an excellent resource. They're gorgeous. I strongly recommend you take a look at them if you're interested in learning more about information visualization or graphing. But then again, low data ink is not the only goal you might have. So while I would say in general you want to strive for it, there's some other things you could think about. How would you compare this graph, looks pretty good from a data to ink ratio, to this one? Well, the latter obviously has this extra embellishments going on. You've got, the slobbering monster, all kinds of things happening. But in a study by Bateman et al., it was shown to be as comprehensible as the plain graph, but more memorable after 2 to 3 weeks. Now, this is initial evidence. You might want to look at follow-up work to see how reliable this is, and it may not be your goal, but it's a chance to be able to, tell more of a story and have more of an impact if that is your goal. So how do they achieve this? Well, the embellishments, which count as non-data ink, this is the chart junk, can help to tell the story and really make an impression. But like I said, you don't want to do this with every graph. It really depends on your goal, and you have to be careful not to distort the data. This was carefully designed, I believe by Holmes, to explain the data in a way that's truthful, still comparable, still comprehensible, but in a way that then also tells a story. And if you don't quite get there, it might be, it's kind of a dangerous line to tread, where you might create a visualization that isn't as comprehensible or could actually explain the wrong things. This is because even small decisions can influence how graphs are read. So what about this graph? What does this tell you? Is the number of nightmares in a week. Looks like people are having a lot of nightmares, right? Well, this is the exact same data presented with a different axis, and it looks like people aren't having very many nightmares a week. Although if you look at it, with cheese versus no cheese, it looks like they're at 11 nightmares a week. That seems quite heavy from my point of view. Or this graph, what do you think is a good graph? I think it's completely misleading because there's no break between the 0 point and the height. You've got people expanding in both X and Y, and so we're perceiving the area of these different giant women, or giant females, I guess, to be specific, compared to these different areas. And so you've got someone who's 5'5" being, 4 times the height as someone who is 5 foot, which is not the case. So it really does tell a different story than what the data might actually tell. Which brings us to this quote popularized by Mark Twain: "There are 3 kinds of lies: lies, damned lies, and statistics." How you structure the graph also determines what you get out of it. So one well-known concept is Simpson's paradox. So with this data, what do you see? You see maybe a negative correlation, right, between the 2 variables. But if you look at the different groups, you actually see a different. So if you look at the data at a whole, you see a negative correlation. If you look at it in different groups, you see a positive correlation. And it's quite a common effect that you have to be very careful of, which is why you really want to think about how you're displaying the different groups in the data, really start to tease it apart and be able to work with the data visually.